it's on there with review or without.
I just wanted to make sure before I hit the bubble.
Yep, it's out there. First page is just like your quiz, basically. You should be doing n minus 2 times 180. Octagon is 8. Make sure you're looking at details like putting a degree onto the sum of the measures in the interior angles. N equals 12 sides. Since classify is being asked for, what's the name of the 12 side figure? Dodecagon. Make sure that you are answering the question. That answers that part of the question. Did we get 8 and 16 for those two? 1, 2, 3, 4, 5, 6, 7, 8. If there's 8 angles, there's 8 sides. So you should have been doing 8 minus 2 times 180. But that's really what we were doing in problem number 1, and that answer was 1080. Equal to everything that's over there. That turned out to total up to 32x plus 824. And then solving that equation will get you x equals 8. What's the total for the whole outside? 360. And you would have ended up with a 7x plus 248 equal to the 360. Page 2. You tell me. Somebody raise their hand. Give me what you got for 5 and 6. Elizabeth? 120 and 60. Let's label things. Put something down so I know you understand which one's the interior and which one's the exterior. And how about the next one? If I'm doing this, I'm taking care of the exterior first. I'm doing a little bit of division with 360 with my hexagon. That gives me the 60 on the outside, and then a little bit of subtraction gets me the 120. Find the value of n. If we're looking for n, what are we really looking for? Number of sides. As soon as regular shows up, I know I can do some division. I'm being given the exterior angle, makes it even easier. Ten sides, and that's all I need. I didn't need to classify this stuff. Interior. If I'm going to do this, I'm going to save myself some time and energy. I'm thinking to myself, I've got some figure with some exterior angles. Inside is 150. What's on the outside? 30. Now it's just like that problem. I just do a little bit of division with 360. 12 sides. Now, did somebody else do this problem by just dealing with the inside? Did anybody do that? You can do that. You can figure out that n minus 2 times 180 divided by the number of sides is equal to 150. By solving that equation for n, you'll get directly to 12 sides. But this is a little bit quicker. Even if you got these problems right for 9 through 14, after we're through, I would recommend redrawing the figure right below it, F, G, H, E, just so you get an idea of the big picture. What do the big angles look like? So when EFG is given to you, EFG, I can put that here rather than laying it on top of that diagram. It all depends on how you can visualize things. EHF, 45 degrees. EHF. Did everybody place 45 degrees there? These are distances outside. FO4, that's a portion of the diagonal. In a parallelogram, you know that opposite sides are equal. So I would immediately just put a 7 there. You know that diagonals bisect each other. So I would put another 4 right there. Even without looking at any of this, I would start by doing that. I would also, before even looking at this, I would fill in this. It's a parallelogram, so if that's 115, that's 115. If that's 115, that's 65, and that's 65. Have an idea of the big picture before you start looking at what it is that you need. Now let's take a look at this. EHG. EHG is the big angle. Well, we figured out the big angle right here. It's 115. GH, we got a distance. GH is over here. 7. FHG. FHG is the little angle. If that's 115 and that's 45, that's got to be 70. Make sure that you are putting degree measures where they belong and no degree measure where it doesn't belong. HO. HO is the rest of this diagonal, which we already know is 4. FH is the whole diagonal. GFH. GFH is this angle up here. I see my Z shape. Another 45 degrees. Do we agree? For that problem, we were told that is a parallelogram. So we had a certain amount of characteristics we had to think about. This is also a parallelogram. Write that down. The first thing you should do when you look at a quadrilateral is decide what it is. I see arrows. That means parallel. That's a parallelogram. So I'm immediately putting 23 here because I see my alternate interior angles. Now I've got a triangle here that's 180 degrees. That's 66. So that would be 114. $114 for the Y, and we already had 23. Don't. If you're stuck, chances are you've forgotten to do something with a triangle. What is this? If I've got this, what is it? Rhombus. Write that down. So not only does it have all the parallelogram characteristics, since I'm looking at one diagonal, I know that the diagonal breaks this angle up into 2 equal pieces. These are going to be the same. 37, 37, 37, 37, 37, 37. Don't overthink these. What are we looking at for 19 and 20? What is this thing with 4 right angles? Write it down. Start thinking to yourself, I've got all the parallelogram characteristics, but now I know the diagonals are equal. I would immediately put that in there, just to remind myself that I've got isosceles triangles inside of this figure. And within an isosceles triangle, you got base angles equal. So I know that that immediately is another 40. If that is 90 and that's 40, then that's got to be 50, which means we got to have 50 over here because it is isosceles.
Good morning, Bruins, and please excuse this interruption. Please listen carefully. At this time, please excuse the following students for their writing SOLs. Mr. Alonso's fourth period class is to report to lab 1000. Mr. Alonso's fourth period class to report to lab 1000. Ms. Fernari's fourth period class to report to lab 1003. Ms. Fernari's fourth period class, report to lab 1003. Mr. Cresswell's second period class, report to lab 2112. Again, that's Mr. Cresswell's second period class, report to lab 2112. And last but not least, Ms. Lawrence's second period class, report to lab 2119. That's Ms. Lawrence's second period class, report to lab 2119. That is all for today, and have a wonderful day.
We have not only a trapezoid, we have an isosceles trapezoid, which means we have some symmetry, which means I can write 110 there right away. And these two angles always are supplementary, so I know that's 70 and that's 70. What were we looking for? FGH. This angle down here, 70 degrees. 22. Not a isosceles trapezoid, but since I've got this information, I know that M and N are midpoints. So what is MN called? That's the midsegment. What's its relationship to the two parallel sides? How do I determine this? Rachel? Average. I'm guessing that you might see something this easy on the test, but more than likely, the SOL likes to make it a little more difficult by making these two items algebraic expressions. Maybe you'll see x plus 5 there, or 2x plus 6. It's no different. You're going to be adding whatever's there and dividing by 2, and whatever you get is going to be equal to that mid-segment. So what do we got here? 38 divided by 2, 19. Is that what we're looking at? You can put that. In addition to that, put some arrows on all three. Not only is that the average of the two parallel sides, but it's also parallel to those parallel sides. You might see some kite questions on your eventual test. You've got some symmetry, but not necessarily in both directions. Since this equals this and this equals this, these two are going to be the same. How many degrees are left over if you've got 60 and 50 so far? So we got 250 left over. Split that up into 125, 125. You want to make sure that everything totals up to 360 when you're through. Notice we don't necessarily have anything that's supplementary like we did in the parallelogram. That's because, not parallelogram, trapezoid. That's because nothing is parallel in the kite. JKL, JKL, 125 degrees. It's hard to see what's going on in this proof down here. We're trying to prove that two triangles are congruent. Darken those triangles in. ART is this one, and ACE is this one. when you are filling in pieces of a proof, you've got to look at what your end result is trying to accomplish. So everything in here should lead you to that. So we're interested in the angles that are inside of there. ART is there, ACE is there. Given rectangle, RECT is a rectangle. That should go there. RT congruent to EC. Let's put that in. That's this right here. And RT is parallel. Put some arrows in to show that. What do you think you should put for number 2? I would accept a lot of different things there. What do you think you should put there? I wouldn't write definition of a rectangle, because what is truly the definition of a rectangle? What makes a rectangle a rectangle? 4 right angles. So if this said that all of the angles were right angles, then I'd write definition. What I would write would be if quad is rectangle, then op sides are congruent and parallel. I would actually write out what is happening. We're saying that opposite sides are congruent, and we're saying that opposite sides are parallel. Those are characteristics of a rectangle. For number 3, we're working backwards. We know what we would like to talk about. We'd like to talk about alternate interior. But it's got to be inside of the triangles that we're attempting to get to. So if I'm being told that those are the triangles, and I want alternate interior angles, then I would either go for this one and this one, or the other 2. I'm just going to go for where I put the dots. That would be angle TRA congruent to ECR. But you could have put this angle here and this angle here, the E and the T. Use 3 letters. If you just say angle R, I don't know what you're talking to, or angle C. Give me 3 letters when you're describing the angles caught here and here. Then it mentions vertical angles. Well, I want vertical angles that are going to help me with these triangles. So I'm probably looking at these 2 right here. That's angle RAT congruent to angle CAE. Don't forget what we're trying to do. We're trying to prove triangles congruent. SSX, ASA, etc. What do I have inside here? That's equal to that. We got vertical angles, and you have these 2. What are you looking at? Which reason? Which combination of S's and A's? Yes. And don't be afraid to write things out longhand like this if you're given a proof and you got to fill in spaces. Don't think that you have to have a specific name. Every textbook has different names for all these different little theorems and postulates. If you just write out what you're thinking, chances are it's what I want to see. Number 1 mentions rectangle. Number 2 mentions some characteristics. So write it out as an if-then statement. That's a good basic overview of what your test looks like. Your test will have, I think, all multiple choice questions, except for the proofs. be a couple proofs in a separate section. It might look like. Whenever you are given proofs or see proofs on a test, I'm going to give you way more lines than you need. So the first one has, I don't know, maybe a dozen lines. It does not mean that it's going to be a 12-step proof. This could be 5 or 6 lines. Don't ever feel that you have to fill in all of the lines that I give you, just to give you space.